Hi, my name's Cooper, and today I'm going to be explaining critical points, what they are, and how they work. Critical points occur in graphs when the derivative or the slope of a graph at a certain point is either zero or does not exist. They also have to be within the domain of a function, so appear on the graph of the function. All right, let's look at an example. Here we can see that this graph has three critical points. The first one on the left is a critical point because the derivative of the function at that point does not exist. The other two are critical points because there the slope of the graph is equal to zero. Now, how do we find critical points when given the equation of a function? A critical point exists when the slope of the graph is equal to zero, as we said. So therefore, to find these critical points, we take the zeros of the first derivative equation. Here's an example of finding the critical points of a function. Here we have our first function, which is 6x cubed minus x to the fourth. Now we need to find the derivative equation of this. As you can see, the derivative is 18x squared minus 4x cubed. And we set that to zero because we need to set it to zero to find the derivative. Then we can factor out a 2x squared, which gives us 2x squared times 9 minus 2x. So we take the zeros of that, which gives us x equals 0 and x equals 9 over 2 as the values that give us a derivative of 0. Therefore, the critical points are at x equals 0 and x equals 9 over 2. Now, what do critical points really mean in a graph? Critical points show local maximum, local minimums, and inflection points, or anywhere the graph changes in either direction or concavity. Here's an example of a local maximum we see on the left and a local minimum we see on the right. Those are both critical points because there the slope of the graph is equal to zero. Here we have an inflection point where the concavity of a graph changes. We can see here the concavity is down and here the concavity is up, and in the middle is the inflection point where the slope of the graph is equal to zero. Critical points are important when doing the first derivative test on a function. For the first derivative test, the critical points show us exactly where the direction or concavity of the graph changes. All right, now let's apply critical points in the first derivative test. Here we have a function and we're trying to find out where its maximum and minimums are, and the critical point test is going to help us do this. First, we take the derivative of the function and take the zeros, which gives us critical points at -4 and 3. Now we make a number line and mark down our critical points at -4 and 3. And we show that here the critical points are where the derivative of f of x equals 0. We plug in values less than -4 and we see that all of them are positive. So we know the derivative here is positive. Now we plug in values between -4 and 3 and we see that all of those are negative. So the derivative here is negative, and then the same thing for this side, and we see that it's positive. That means the actual graph is increasing here, decreasing here, and increasing here, making this a maximum because it goes from increasing to decreasing, and this a minimum because it goes from decreasing to increasing. Critical points are also important for the concavity or second derivative test because, as we can see, these 2 points show where the concavity changes from upwards to downwards, or vice versa. All right, now let's look at another example of finding critical points from a function. Here we have x cubed minus 5x squared minus 8x plus 12. Now to find the critical points, we need to find where the derivative is equal to 0. So we find the first derivative equation and find the zeros. The first derivative equation we have here, and then we need to factor this. Factored, it is 3x plus 2 times x minus 4 equals 0. Now we can see the zeros are -2/3, comma 4, and these are our critical points for the graph. Thank you, that was my presentation on critical points.